Have you ever pondered how the universe, sprinkled with galaxies, stars, and planets, got to be as vast as it is today? It's an intriguing thought, isn't it? But first, welcome to my channel. We're not just floating in a static cosmic sea. No, far from it. Our universe is alive, dynamic, and continually expanding. This ceaseless growth, an unfathomable phenomenon, traces back to a single, monumental event. The expansion of the universe is a fascinating journey that began with a single, monumental event. The birth of our universe sparks from a single phenomenal event known as the Big Bang. This isn't just a theory but the most widely accepted explanation of how our universe came into existence. Picture this. Everything we know, all the matter, all the energy, all the galaxies, stars, planets, and even space and time itself, compacted into a point of infinite density and temperature, a singularity. This singularity existed in a state of stability, until something triggered it. Suddenly, approximately 13.8 billion years ago, there was an explosion. Not an explosion like the ones we're familiar with. No, this was an explosion of incomprehensible scale, an explosion of space itself. In a fraction of a second, the singularity expanded rapidly into a space billions of miles across. In the wake of this expansion, the universe was a hot, dense sea of particles and energy. As it continued to expand and cool, particles began to combine, forming atoms, then stars and galaxies. And so the universe as we know it began to take shape. It's important to understand that the Big Bang wasn't an event that happened at a particular spot in the universe. There's no epicenter you can point to, rather it happened everywhere at once. The Big Bang was not just an explosion in space, but an explosion of space itself. The aftermath of the Big Bang set the stage for the universe we know today. What followed next, in the blink of an eye on a cosmic scale, was a period of rapid exponential expansion, known as inflation. This inflationary period was much like a balloon being blown up, stretching and smoothing out the universe, but at a pace that is almost unfathomable. It was during this time that the universe grew by a factor of about 1,000,000 trillion, in less than a trillionth of a second. As the universe expanded and cooled, a flurry of activity began. Particles started to form, the first of which were quarks and gluons. These tiny particles danced and swirled in the heat of the early universe, eventually combining to form protons and neutrons, the building blocks of atomic nuclei. As the universe continued to cool, these protons and neutrons began to form atomic nuclei, a process known as nucleosynthesis. The first atoms to form were hydrogen and helium, with traces of lithium and beryllium. For hundreds of thousands of years, these atoms filled the universe, creating a dense, hot soup of particles. But the universe was not content to remain a hot, dense soup for long. As it continued to expand and cool, the first stars began to form, igniting in a burst of nuclear fusion. These stars clustered together, forming the first galaxies. Now, you may wonder, what propelled this expansion? This is where dark matter and dark energy come into play. Dark matter, an invisible substance, makes up about a quarter of the universe and plays a crucial role in galaxy formation. Dark energy, on the other hand, is the mysterious force that is causing the universe to expand at an accelerating rate. From the primordial soup of particles, the universe began to take shape, ever expanding due to the mysterious forces at play. The universe as we know it is a marvel of cosmic evolution, a testament to the power and majesty of the forces set in motion in the aftermath of the Big Bang. Fast forward to today and the universe continues to expand at an accelerating pace. But how do we know this? What evidence supports this cosmic assertion? Well, one of the primary pieces of evidence is something called the redshift of galaxies. You see, when we observe distant galaxies, we find that their light is stretched or shifted to longer, redder wavelengths. This is very similar to the Doppler effect, where a car's horn sounds different as it approaches you and then drives away. The shift in the light's wavelength suggests that the galaxies are moving away from us, and the further away they are, the faster they're moving. This observation provided the first hint that the universe is expanding, but there's more. Another compelling piece of evidence comes from something called the cosmic microwave background radiation. This is the afterglow of the Big Bang itself, still visible today as a faint glow of light that fills all of space. This radiation is incredibly uniform, suggesting it comes from an early, hotter, denser state when matter was spread out evenly. As the universe expanded, this radiation cooled and stretched to the microwave wavelengths we see today. So, how do scientists measure the rate of this expansion? They use a value known as the Hubble constant, named after the astronomer Edwin Hubble, who first observed the universe's expansion. By measuring the redshift and the distance of a variety of galaxies, scientists can estimate the expansion rate. However, there's still debate about the exact value of the Hubble constant, which is one of the biggest unsolved questions in cosmology today. In essence, we're living in a universe that's not only expanding but doing so at an ever-increasing speed. It's like we're on an endless outward journey with galaxies as our milestones whizzing by faster and faster. It's a fascinating, mind-bending concept, isn't it? As we gaze up at the night sky, we're not just looking at stars, we're witnessing the incredible ongoing expansion of the universe. The journey of the universe, from the Big Bang to the present, is a tale of continuous expansion. Born from a singularity, an infinitesimally small point, our universe exploded into existence in a fiery spectacle we call the Big Bang. Following this event, the universe underwent an inflationary period, expanding at a rate faster than the speed of light. This phase set the stage for the universe as we know it today, laying down the seeds for galaxies, stars, and planets to form. As time marched on, matter began to coalesce, giving birth to the first galaxies. Fast forward to the present day and we find ourselves in an accelerating universe, growing larger and larger with each passing moment. The story of the universe's expansion is a cosmic ballet of energy, matter, and gravity. As we delve deeper into the cosmos, we continue to unravel the mysteries of our ever-expanding universe.